So earlier this fall, I designed a custom tattoo machine power supply for an artist named Blake Wood. I figured I'd make a quick video on the design process and also provide an overview of how it works. A tattoo machine consists of 2 coils, an armature bar, a contact screw, a tube, and a needle. When DC voltage is applied, the coils are charged, which turns them into an electromagnet. They begin to draw the armature bar closer, which also moves the needle downward. When the contact screw is touching the armature bar, the circuit is complete. With it now disconnected, however, the coils lose their charge and the armature bar returns to its original position. This happens multiple times a second and is what allows a tattoo artist to put ink into the skin. To turn on the unit, flip the switch on the back. After a quick splash screen, one of the small red LEDs on the front illuminates to indicate which channel is active. To increase the voltage on that channel, press the up button, or simply hold it down. To decrease the voltage, do the same thing. You can do this as many times as you wish until the desired voltage is achieved. After setting the voltage, press the large push button on top to activate the tattoo machine. The LCD display shows the active channel and its voltage. It also shows the CPS, or cycles per second, which is the amount of times per second the coils are charged and discharged, and the duty cycle, which is a fraction of the amount of time in one cycle that the coils are active. To use the second channel, press the select button on the far right. Normally you'd have 2 tattoo machines plugged in at the same time, but for the purpose of this demo, we are only using one. Notice the display and the red LED show that channel 2 is active. To turn on the Bluetooth speaker, flip the white switch on the back.
Bluetooth mode. The Bluetooth device is ready to pair.
Turn on the Bluetooth transmitter on your phone and search for the new device. When it is paired, it should display that it's connected.
The Bluetooth device is connected successfully.
I first prototyped the idea on a breadboard. Once I was happy with the way it functioned, I drew up a proper schematic. The microcontroller I used for this project was the PIC16F88, which I programmed in PIC Basic Pro. This is what handles almost every operation the unit performs. One of the main things it does is it communicates with the DS1868 digital potentiometer, which I use to control the voltage to each channel. I am also using an INA138 high side current monitor to create a square pulse every time the coils are active. The PIC measures the width of these pulses and the time between them to find the duty cycle and the CPS. To design the board, I used the program called Eagle. I then made the first PCB using a CNC mill. Once that was working correctly, I fixed some minor errors and sent my order into a PCB fabrication house. Rather than start from scratch, I ordered a pre-made Bluetooth module from eBay. I also ordered a Class D amplifier board as well. To make the front panel, I made the design in Eagle and milled the image in reverse onto painted plexiglass. I later painted over the reversed milled out image with white paint and ended up with a pretty good result. After the first unit was finished, I bought another enclosure to experiment with different finishes. I tried gold finish and even tried using vinyl car wrap, which ended up working quite nicely. In the future, I plan on using a color screen so I can display moving images and different colored text. I also plan on using colored buttons instead of LEDs. If you have any questions or would like to see a more detailed write-up, visit my website at www.mrelectronics.net. Thank you for watching and please subscribe.